a little bit about your background, what you do, how long you've uh, participated in research with cloud seeding?
Okay, yeah, I am. My name is Bart Geerts. I am a professor at the University of Wyoming. I do research on clouds and precipitation, the dynamics of storm systems over the mountains and the plains, wintertime storms as well as summertime thunderstorms. Um, we have a research aircraft, University of Wyoming, uh, King Air, with radars, lidars in situ, cloud and precipitation sensors, and that's been the primary source of data for my research. We do a fair bit of modeling too. In the last 15 years, we've gotten ourselves involved with the cloud seeding research that many Western states are interested in. Cloud seeding is a practice, an operational practice that goes back many decades, primarily, at least in the Western US, to enhance the precipitation, the snowpack over the mountains. The West is fairly dry, and any extra precipitation, snow on the mountains helps in terms of availability of water, especially in the warm season. So Wyoming had a weather modification pilot project back in about 15 years ago that involved me, and we got some funding from the National Science Foundation to work on that with our King Air and a series of additional instruments on the ground. And there's been a number of additional campaigns since then to demonstrate whether this cloud seeding works.
For the people at home who don't have a detailed understanding of cloud seeding, what exactly is it and how does it work?
Yeah. So the idea in a nutshell is that natural clouds tend to have a fair bit of supercooled liquid water, especially when the atmosphere is very clean, like maritime air. At temperatures well below freezing, there's still supercooled liquid water droplets, small droplets typically, sometimes somewhat larger drizzle-sized droplets. And they don't freeze immediately because of a lack of ice nucleating particles in the cloud. Um, Homogeneous freezing, whereby pure liquid freezes, only happens at very low temperatures, like minus 35 to minus 40 Fahrenheit, really cold conditions. Um, Most clouds are frozen at temperatures below about minus 4 Fahrenheit or minus 20 Celsius. Um, because there are some ice nucleating particles out there naturally. But in the temperature between, well, minus 5 and minus 20 Celsius, so whatever that is in Fahrenheit, 22 to minus 4 Fahrenheit, in that range, um, you can have supercooled liquid in the clouds. And there are seeding agents that initiate ice at those temperatures. There's various products are being used. Silver iodide is the most commonly used one, and it's most effectively dispersed through pyrotechnic techniques, basically burning sticks of silver iodide produces very tiny aerosol in large numbers, and they all act as ice nucleating particles upon which ice crystals can form. Once you have those ice crystals in the cloud, then the supercooled water will essentially disappear, sometimes fast, sometimes more slowly, depending on the number concentration of those ice particles. And we've shown that with the aircraft observations that basically the liquid is depleted and the ice crystals grow at the expense of the liquid. And that's because there's a vapor pressure difference between ice and water. Ice is hygroscopic, if you like, at those temperatures. If you may have put your tongue on a pole, a metal pole, at very low temperatures in the winter and regretted it because your tongue gets stuck. That's because there is some pressure differential, and basically your tongue is drawn upon the pole that stays cold. Uh, It's that vapor pressure difference that draws the liquid towards the ice. The ice crystals grow to snowflakes. They fall down, produce snow that otherwise would not have fallen. Um, it's called glaciogenic seeding. Seeding whereby you introduce ice in a supercooled liquid cloud so that the ice falls out and produces precipitation, typically over mountains. That's where you target your seeding because supercooled liquid is most common in these orographic clouds.
Kind of touching on that, can you point to specific examples or case studies where cloud seeding has had measurable success? And then how do scientists quantify or measure the effectiveness of cloud seeding?
Yeah, good questions. Cloud seeding has really been in the Wild West, so to speak, for decades, ever since the idea of seeding clouds was first proposed back in the late 1940s by some engineers at General Electric. Um, there have been a number of experiments over the years to demonstrate its efficacy, and the claims that were made back in the 60s and 70s were wildly overblown and really not supported by good measurements. Um, and you know, back then in the 1970s, 80s, the Bureau of Reclamation and other groups spent a lot of money on cloud seeding research as a way primarily to make the Western US weather. There were other objectives, like, for instance, deflecting hurricanes, but I don't want to talk about that. um, Seeding is also used to suppress hail in some big thunderstorms in the Great Plains. I don't want to talk about that either. Um, the seeding to enhance precipitation um, drew a fair bit of attention in large campaigns, the largest of their days in the 1970s in Colorado and elsewhere in the Western US. And a lot of papers were published, but the results were also questioned. And then the Bureau of Reclamation, the funder, or the primary funder, basically decided to stop funding it in the late 1980s because the evidence was really too inconclusive or contradictory. There were questions about the validity of the results. And then cloud seeding research at least stopped for 2 decades. Although the operational cloud seeders continued to seed wherever, especially when there was a drought in various Western states, through the 1990s, 20s. Um, and then around 2006, 2007, the state of Wyoming started with a cloud seeding program following a drought, a pretty large one, $10 million ground-based seeding. And we got a proposal funded to piggyback on that by the National Science Foundation. Um, and the preponderance of the evidence of that work is that cloud seeding does increase snowfall and the number concentration of ice crystals, but the evidence was not as crystal clear as it could be with airborne seeding, as it was shown later on in another campaign in Idaho that was also funded by the National Science Foundation and piggybacked on seeding work that was done by Idaho Power for them to increase electricity production at their hydroelectric dam, and then later also funded by the agricultural community of Idaho. And there we had seeding from an aircraft in very specific pockets of supercooled liquid water. And we demonstrated unambiguously that you could enhance precipitation. The way we did this is by flying a seeding aircraft back and forth across a supercooled liquid cloud, orographic cloud. And the wind would move the seeding material to the side because we were flying across the wind along the mountains. You can picture that. And the seeding material would be flowing off to the east in this case by the westerly winds up there. And because the aircraft went back and forth, the seeding plume followed essentially a zigzag pattern. You can picture that, right? It was blown off downwind. It left behind a zigzag pattern. And then we saw enhanced reflectivity in the form of that zigzag by radar, ground-based radar, and also radar that we had on a separate aircraft, our King Air aircraft. And we did some measurements within those seeded plumes, and we found, more numerous large ice crystals. And so that demonstrated to the public in general, anyone, really a 6-year-old, can see those zigzag lines in the clouds and on the radar reflectivity map and say, yeah, there is something there that seems to be man-made that cannot be natural. Um, and it's almost like contrails, for instance, that an aircraft leaves behind it, as it's so apparent. And so we published that, and that really built the foundation for more cloud physics research in cloud seeding. And we now have numerical simulations that we apply for the entire seeding season that Idaho Power did back then during that campaign. To demonstrate the impact. Impact tends to be pretty small and uncertain still. These simulations are ensemble simulations where we vary a number of parameters. And our work in Wyoming indicated maybe a couple of percent of increase in precipitation, no more than that, and statistically not quite significant. In Wyoming, in Idaho, the seasonal seeding results are not final yet. So I cannot say to what extent the seeding increased the precipitation there. That was not a randomized experiment, but still we're trying to quantify this. It's not the numbers that were claimed back in the 60s, 70s, 80s, where they were talking 10, 20, 30% increase in precipitation. It's more like a couple of percent of increase in precipitation, it appears.
Are there any known or theoretical unintended consequences of cloud seeding that you're aware of or comfortable discussing?
Um, well, unintended consequences in a way are the change in precipitation downwind. It's long been a concern that if you, what's the expression, take from Paul to give to Peter, or vice versa, I forget what that expression is. Basically, if you enhance the precipitation in your target area, you may decrease it further downwind. It appears that silver iodide ice nucleating particles are not all activated in these orographic clouds, and that some nuclei stay behind further downwind. That's been observed. That's also been simulated. And then further downwind, if there's enough water vapor and supercooled liquid water, then they can enhance precipitation there as well. So they could enhance downwind areas, enhance the precipitation in downwind areas. They could also decrease it somewhat because some of the water vapor has been consumed in the airflow. In a way, that's an unintended consequence simply because cloud seeding targets a very specific watershed, right? As far as environmental concerns about silver iodide in the snow and then in the stream flow when that snow melts, and ultimately in the soils, um, there've been a number of studies to demonstrate that the background concentrations of silver, not iodide is volatile, it escapes in the atmosphere, but the silver stays behind, and the concentrations of silver are quite small, typically not detectable in the stream flow or in the soils, downwind of silver iodide generators. Because there's natural sources of silver in most mountain areas. And so the environmental concerns are pretty small. Still, they need to be monitored, especially precisely downwind at close range from the ground generators, because that's where you expect the silver iodide concentrations to be the largest. And if you do that for a whole season or a number of seasons, there could be some effect. And the various groups that do the seeding actually do take soil and snow samples and stream flow samples to check on concentrations of silver.
given the recent floods in Texas, the general public or a lot of people are trying to connect cloud seeding to that. So, kind of touching on that or just extreme weather events impossible, or, extreme weather events in general, is it possible that cloud seeding could contribute to localized extreme or high impact weather events? Kind of why or why not, if you're comfortable discussing that.
Yeah, yeah, there have been claims in social on social media about the possibility of cloud seeding somehow enhancing the disastrous floods in central Texas in the Guadalupe watershed there. Um, and indeed, there was a company that was seeding there up to 2 days in advance. They stopped seeding um, on the 1st of July, I understand, in that event. And they were not quite in that same watershed, but nearby. Um, and just in general, based on our experience in the field and based on numerical simulations, this seed material doesn't last very long. It gets absorbed by cloud particles and it rains out very quickly, as any aerosol particles would. In the course of hours, not days. So any seeding effect would have long disappeared after 2 days. And even, and that can be demonstrated through numerical modeling. Um, and even if you were to be seeding those clouds in Texas while they were active in that night from the 3rd to the 4th of July, with airborne or ground-based seeding, as I said earlier, the changes are pretty small, a couple of percent. Now that's significant, if you have like a 20-foot rise in the water level, an extra 2% would give you another what is it, 0.2 feet, right? 2% would be 2.2 feet, and that is what is it? 1/5 of a foot. That's a couple of inches. That can be significant, of course. I don't want to diminish that importance, but in the total picture, it would be pretty small. And that just in the hypothetical situation that you were seeding during the event in the inflow region of those the big thunderstorm complex that formed over central Texas on that night of the 3rd of July. There was no seeding done at that time. I'm just telling, hypothetically, if it was done, it could have affected it. But it's very difficult to quantify the impact of seeding in thunderstorms in general. They can do this numerically. The models are now fairly well constrained. These are models that resolve the convection and also resolve the cloud macrophysical processes that basically enhance the ice initiation and then produce extra snow particles. It's perfectly possible that cloud seeding would actually diminish the precipitation in such conditions. There's no reason to expect only an enhancement. Again, the effect would be small. It may be that more ice particles would result in more anvil development in the convection and less precipitation on the ground. And that's why they actually see convection in the Great Plains in some regions. It's hail suppression. It's to basically produce more numerous small ice crystals that don't grow into hailstones, basically allow for more effective outflow of that convective updraft in the upper troposphere, and thereby suppressing hail. So it's really not clear how cloud seeding would have affected the flooding in Texas. But anyway, no cloud seeding was being done. So in a way, it's all moot.
How is cloud seeding regulated in the US? Is there federal oversight or is it more state by state?
Um, well, there are uh, in some states there are restrictions about cloud seeding. In recent years, some states have imposed restrictions on geoengineering, and they may have included cloud seeding in in that geoengineering bill. Geoengineering is very different from cloud seeding. It deals with the alteration of the climate. Uh, Through processes that involve clouds, you can have marine stratus brightening by increasing the number of ice particles. So more uh, cloud condensation nuclei lead to more numerous droplets, leads to brighter clouds. That's marine stratus brightening. You can also diffuse upper level clouds, the cirrus clouds, if you can somehow diffuse them faster, because cirrus clouds tend to have a warming effect. Marine stratus tends to have a cooling effect on the climate. And there's also a direct aerosol effort in geoengineering, that is an injection of additional aerosol in the stratosphere that is long lasting. Above the troposphere, in the stratosphere, aerosol injections. Those are all geoengineering efforts, and some states have banned geoengineering efforts. And some states have included cloud seeding in that geoengineering. Again, cloud seeding is different. It works on a much shorter time scale. Nothing to do with the climate. It's all about local precipitation enhancement. On the finer scale, you can increase precipitation, snowfall, if you like, within, say, ski areas or a golf course. Or really locally, you can do that with um, these snow guns in ski areas. You may have seen them, where they basically blow snow out. That's basically water that's converted to snow. They put some snow max, which is Pseudomonas syringae, that easily freezes the small pressurized droplets that come out of the gun and makes snow, and then that gets spread out over the ski area. That's a smaller scale. Cloud seeding is a larger scale that covers maybe entire ski areas and mountain ranges and beyond, maybe tens of miles in area. And basically, there you seed natural clouds, supercool liquid clouds. Geoengineering really deals with the global climate. Anyway, about the regulation. Marjorie Taylor Greene, Republican from Georgia, recently introduced a bill at the federal level uh, to ban geoengineering and cloud seeding. But that's only a proposal. And at this time, really, there is no federal oversight on cloud seeding. It's always been done through support by whomever is interested in it. That could be municipalities, agricultural co-ops, utility companies like Idaho Power, states, electricity companies. Yeah, yeah. Colorado River Basin, also so water interests. So it's been supported by various interests to enhance the precipitation. They figured that even while the impact of seeding is uncertain still, that there are no significant environmental risks, and so the cost is worth it, even if the outcome is uncertain. After all, that precipitation, the extra precipitation that falls, is considered natural in a way that it's like an act of God in terms of the water rights. The precipitation that falls is subject. The extra precipitation, cloud seeding precipitation, is subject to the same water rules um, as natural precipitation. So whichever watershed it falls in, it becomes part of the natural flow, and then it's subject to the same water rights as natural water. And water rights are a big thing in the Western U.S., as you may well know. They say that whiskey is for drinking and water is for fighting in the West. Because so water itself is pretty tightly regulated, but the seeding is not.
Speaking about the Western states, could cloud seeding techniques be utilized to assist in wildfire containment efforts?
Not directly. It would not be wise. No. For one, when there's a wildfire, there's so many natural aerosol, that additional aerosol from seeding really makes no difference. And some big wildfires actually produce their own cumulonimbus clouds, pyrocumuli, as they're called, and they sometimes produce precipitation, and they may suppress the fire. Um, but really, no, it's not a suitable tool to get precipitation at the right time, at the right place. Maybe indirectly by increasing the soil moisture. If you do seed a mountain range the winter before and have a better snowpack, you have more soil moisture in the spring, then maybe wildfires are less likely. So, in that broader sense, if you have more moisture in the woods, in the timber, then maybe they're less prone to wildfires. Yes, that's very indirect, though.
And this will be the final question. Are there any misconceptions about cloud seeding that you would like to clear up or maybe elaborate on that you've come across on social media or you've just heard in general? Or do you have any closing statements about cloud seeding and its importance, just so people at home have a better idea and understanding of cloud seeding?
Yeah, well, I'm a researcher. I've been working with many others. It's a fairly small community of maybe 10, 20 researchers across various institutes on cloud seeding. And if cloud seeding were to be canceled because of concerns of somehow, messing with nature, um, I would say, the cloud seeding itself is not like geoengineering. It's something very local, very limited, very short-lived, and it's still pretty poorly understood. And if we do want to, water is important. Water in the West really is important because it constrains the population, the economy. If we do want to um, understand cloud seeding as it's being done, it had been done for decades. We got to do some more research in that area. It's actually very limited research that has been done with the recent tools, observational and computational tools that we have today in cloud seeding. So I would encourage more support, coordinated support, a big field campaign to better understand cloud seeding, because really what we have done is only, a very small part, very few storms have been sampled, and we're just lifting a very small part of the puzzle here. So I hope that the current concerns about geoengineering don't end the cloud seeding research. I guess I want to leave it with that.
Well, thank you. I really appreciate your time and insight. You're
Hmm.
a leading expert in the field, and I think your voice and your voice of reason is important for the viewers who ever watch this video. So I'm really, really appreciative for your time, and yeah, I learned a lot today, and I hope a lot of other people learn a lot too.
Yeah. All right. Well, thank you very much, Chris. Thanks for your efforts in general to eradicate these misunderstandings, misconceptions, and to get the word out. Appreciate it.